anytime they give you sample data, yeah, this message was approved, right? Okay, anytime they give you sample data, you are going to use a t-interval because you're coming up with the standard deviation and you're gonna, you've come up with everything, okay? So the difference between this, this interval and the intervals that we've been doing for proportions is just slightly different. And in this problem, you guys, for 1031, they told us 95% confident, right? So we're going to put 95%. If they don't tell you, you guys, just go ahead and use 95, okay? So our confidence interval is going to be x bar plus or minus t star. Remember, t star comes with degrees of freedom. And then it's going to be s of x divided by the square root of n. Now let's go over a couple things, okay? The whole thing is called the confidence interval. This is how you find the confidence interval. Everyone with me? This part, just this part, is called the what? These two things together.
Is it still called the margin of error?
It's still called the margin of error. The t star is called, yep, the t star is the critical value. And s of x divided by the square root of n, there's two different names. What's the first name we learned last chapter?
A standard error.
It is called standard error and standard deviation. You'll see it either way, okay? Whole thing, confidence interval, t star, critical value, t star plus the standard error, margin of error, and remember, this is the standard error. Now, yesterday we put some stuff in our calculator, right? So let's go ahead and get that. Let's, we need all that information. So we need the x bar, and we did a stat calc one variable. So Jeffrey and Gianna, on page 1031, I'm sorry, not page 1031, on page 650. So this is what we got when we put that problem 1031 into our calculator. So is this what you guys got as your x bar, 18.48? And then we're going to use s of x. Don't use sigma because that's population. We're going to use s of x because that's our actual standard deviation for this problem. And we're going to do 4 places out. So we're going to use x bar, which was 18.48. We're going to look up t star in a second. S of x would be 3.1158. And you guys, I forget, was there 20? There was 20 in our sample size, correct?
Yeah.
Right? And now we're going to look up t star. So Gianna and Jeffrey, to look up t star, you're going to go to the back of your blue book. E-learners, you're going to go to the back of your blue book. Your sample size was 20, so what's our degrees of freedom?
19.
So I'm going to put sample size was 20. Degrees of freedom is 19. So we're going to find 19 and we're going to scroll over to 95 or scroll over to 95 up to 19. And what do you guys get?
2.093.
Now you guys, a lot of times they'll do a couple different things for you on an AP exam and multiple choice. Sometimes they'll ask you, what is the formula? Like they'll just ask you this part, and then sometimes they'll ask you just for the interval. And they'll give you Z star. Listen, they're gonna play that the fact that you're gonna forget the degrees of freedom. So you'll give you the T star for 20, they'll give you the T star for 20, they'll give you a Z star, and then they'll give you a couple other things. So that right there is the formula. Now let's go ahead and put it into our calculator. So let me show you. So we're going to go to stat over to test. Elliot, you're going to go over to interval, okay? Now we're going to scroll down, and this is a T interval, okay? This is different. You guys, anytime it's a proportion, it's going to say like 1 prop, 2 prop. This is a T interval. We know this because we wrote T interval. I want you to hit enter. Now, they're going to give you 2 things. They're either going to give you data or stats. Did you enter something into your calculator? Like, did you have to put, I shouldn't say that. Did you have to put something into a list to get your information? You did. So that means they gave us data. Anytime you enter something into a list to get your mean and your standard deviation, they gave you data. And then where did you put your data? I put my data into list 1. Where did you put yours? Frequency is always 1. You won't ever change that. We want to be 95% confident. How did I know that? They gave it to us. And then we're going to hit calculate. Notice it should match everything that we had, right? There's my X bar. There's my standard deviation. And then they gave me my interval. So we're going to write my interval down. So the interval would be 17, comma, no, not comma, 0.022, comma, 19.938. So that's our interval. What questions do you have?
What's the difference between a T-star?
The difference between a T-star and a Z-star. A T-star is they gave us data, and we're going to, okay, so they gave us data, and they also gave us S of X. A Z-star, they give us for means, right? Not for, you always use Z-star for proportions. For means, the only time you use Z-star is if they give you sigma. So Z-star for means is like perfect, right? They give you that sigma. Well, you guys, we live in the real world, and very rarely they're going to give us sigma. If we knew sigma, we probably would know the population mean. Does that make sense? Because Z-star, because the whole reason that we look for population is because we don't know it. And if we know the population standard deviation, we probably know the population mean. So Z-star is when we don't know population standard deviation. Okay, so now we're going to write our conclusion. So far, this right here will give you 3 points. Everything that we just did, stating that parameter, stating our conditions, naming the test, showing the formula, showing this right here, 3 points. This is the part right here now that, remember when I told you if you're going to lose a point, let's lose it big? This is losing a point that's big. If you're like, I have no idea how to write the conclusion, and you're going to leave something blank, okay, that's a point. But if you're going to forget to round to the nearest, like you don't go 4 decimal places out and they specifically want that, or you don't write, you reduce the fraction when you should have written it as unreduced before you reduced it, those are the type of points that I don't want you to lose, okay? So, what are we? So what does this mean? This means we are 95% confident that, now we're going to go back to the parameter. Remember we wrote the parameter out yesterday? We wrote what mu was. Now we're going to write that sentence. We are 95% confident that the true population mean of gas mileage of this one vehicle. And if you guys wrote this type of vehicle or this vehicle, that's fine. So we are 95% confident that the true population mean of gas mileage of this vehicle is between 17.022 and 19.938. Were any of our oh, sorry, guys. Were any of our conditions violated? Did we write proceed with caution on any of them? Then we're good. You guys, if you wrote proceed with caution, you would have come back here and said the normality, with the normality, like if let's say normality was violated, you would have said the normality condition was violated, so we probably should not generalize about this population. Or we should probably go back and prove normality, yes.
Or is there a way to say that without using the word probably?
The condition of normality was violated, therefore we need to go back and check it. Or not, we should not, I can't think of the word, generalize about this population. That's what it said. Because the normality condition was not met, we should not generalize about this population and go back and prove normality. Yes.
Is this kind of just like a general question about like the conclusion?
Okay, so we're doing page 659, number 1039, and we're going to talk about a big toe problem. So the first thing we knew is they gave us data, right? So what do we have to do? We're going to have to put it into our list because we're going to have to create a box plot. We know that. And then we'll go through. And then we'll talk about, I want to talk about the conditions because they're pretty good here. Okay, so go ahead and enter these numbers into your list. So this is what your box plot should look like. Notice it has a what? It has an outlier, but most of the box plot is what? Yeah, it's symmetrical, right? It's approximately symmetrical. Okay, so before we write anything, let's talk about what we know, okay? So what's our parameter of interest? So we have two choices. Is it a P or is it a mu? It's a mu. It's a mean. You guys, proportions, we're not entering anything into a list, okay? Because proportions are like yes or no. We're gonna enter it as like a fraction. Okay, so this was definitely our parameter is a mu. It's a mean. Okay, so now let's talk about simple random sample. Before we write anything down, so we know, did it say it was a simple random sample in the problem? It did, right? Right, it says we are willing to consider these patients as a random sample of young patients. Right there. It doesn't matter. It states in the problem that we are willing to accept this. So that's first thing. Let's talk about normality. We put data into a list. So that means we definitely needed to make a box plot. But what else do we know? What's our sample size? 38. What does CLT state? Yeah, CLT states that if our sample size is larger than 30, then our distribution follows approximately a normal distribution, right? It's approximately normal. The other thing is that the good news is because you also need to not only talk about CLT, but you have this beautiful box plot that you have drawn. And you can say the box plot looks approximately symmetrical, and even with one outlier, so you need to say that. You need to talk about, even though it has an outlier, the box plot is approximately symmetrical, and CLT states that if our sample size is large enough, greater than 30, our sample size is 38, then our distribution is approximately normal.
I don't know why, but my thing doesn't look like that.
Okay, well
It stretches all the way out to that.
Okay, so everything that I'm asking you, everything you're doing, the reason I ask you this is before you start writing it out, because this is what you're doing. You're getting ready to answer that free response question. These are things that you need to think about. What parameter am I using? Does it meet the criteria? Okay, what conditions are there? And everything else you can think of. So, I'm going to move this, and then we're going to talk really quick because the bell, it is like 1:25, and we're going to pack up early because you guys did such a good job for me. So what is our parameter of interest again? Mu. So this is what we're going to write. We're going to write mu. You guys, from now until, especially when we get significance tests, you always state your parameter. You always write your parameter. Now, for confidence intervals, you always are going to write the true, like you're going to start with the true population